Hi, everyone. Today I'm going to talk about climate change in Wilmington, Delaware. I chose Wilmington because in the earlier part of my life, I spent about 4 years living in a suburb just outside of Wilmington in Bear, Delaware. So I have a personal connection to our nation's first state. So my audience is going to be the local government officials for Wilmington, and I'm going to try and convince them why they should be concerned with climate change for Wilmington. So the first thing I want to point out is that according to the Carbon Brief, it points out some very important future goals and what those implications could be if climate temperatures get to those thresholds. So if the world on average increases on temperature by 1.5 degrees Celsius, we're going to see longer heat waves, heavier rainfalls, and we're going to see significant coral bleaching. And if it gets to that 2 degrees Celsius mark, it's going to be much worse. It's going to be 1.5 months of heat waves, a big increase in fresh water, which also translates to a significant sea level rise. So all of these are important factors to consider within climate change and the implications it will have on future food production. And of course, cities that are near bodies of water. This plot is looking at the temperatures from January 1st of 1950 all the way up until April 17th of 2022. And I pulled this big data set, or this big amount of temperature data, to see if there was any outliers that might be interesting and try and maybe tell a story about. So when looking at these data points, a few that stuck out to me personally were, we have data points where the daily high was in the 60s, but the low for that day was in the teens. And then we also have a few data points where the daily high was in the upper 60s, low 70s, and in the 20s. So that's quite a temperature gap or temperature range for the day. And in those days, you will be running your furnace to keep warm, and then your air conditioning maybe in the 70s to keep cool. So those are quite significant. And I thought those were interesting. This scatter plot right here, this is the daily high temperatures for each of those days for that whole time frame. One of the downfalls of this scatter plot is that there's so many data points that it's just very crowded. And one of the things that we can see with this line of best fit, the blue line, is that there's a slight gradient trending upwards, which means that temperature, the data points are increasing as time progresses. The next plot is basically the same as the daily highs, but it's looking at the daily low temperatures. And we can also see that it's almost an identical story. There's a slight, the increase is slightly steeper than on the daily high temperatures. And we can see that, even the daily lows are getting hotter as time progresses. So to better understand what this means, I decided to use regression models. So I ran a regression model for the daily high temperature and a regression model for the daily low temperature. And what I found is that the coefficients from those regression models were both positive. So that means as time progressed, as more days were added into the model, temperature would increase just slightly. So the daily high temperature did not increase at that large of by that much. That's significant of a factor. But when I completed the equation and used my y-intercept and applied that slope and then entered in the number of days, I wanted to see what our temperatures could be expected to increase by within the turn of the century of 2100, like the Carbon Brief pointed out. So if we see temperature increases of 1.5 degrees Celsius or 2 degrees Celsius by 2100, we are going to see some of those possible terrible environmental impacts that we needed to be concerned about. So I looked at the daily minimum temperatures, the daily lows, and within 100 years, so in the year 2122, our daily low temperatures are going to increase by almost 4 degrees Fahrenheit. And that translates to over 2 degrees Celsius. So that's pretty significant. And I know the year 2100 is not 100 years out. It's closer to 72 and change, or sorry, 77 and change. We're in April of 2022. So I factored that into the calculation, and we're going to see a temperature increase for the daily lows of 3.6 degrees Fahrenheit, or roughly 1.7 degrees Celsius. So those are both within the cause for concern for that carbon brief analysis and what those impacts could be. So for the next part of my analysis, I took 1 month, and I took the month of August, and I pulled a month in 1950. So I pulled August in 1950, and then a month of August in 1960. And I continue this all the way up until the year 2020, just to see what that month looks like, every 10 years. And it kind of tells the same picture that we saw with the previous analysis. And this is looking at the daily low temperatures, so that T min variable. And it kind of follows the same trends that we found with that regression analysis. The chart itself kind of makes an M shape. And in the year 2010 and 2020, it's trending upwards with the number of data points and the total temperature. And the interquartile range of that box is shrinking, where as you can compare it to the year 2000, which has quite a bigger range with that interquartile range. But box and whisker plots do a great job of explaining mins and maxes within data points and just the interquartile range. And I added the mean to this chart with the dot. So not just the mode, but also or not just the median, but the mean as well. So tells a pretty good story. Another thing I was interested or curious about was the variances within the data. So I took the difference between the daily highs and the daily lows, and I created a field called delta. And I wanted to see, for that same time frame, what the variances were for delta, because that would tell us when the differences are quite drastic. And from what I could find, in 1990 and 2010, there was variances within that delta variable in 40 and almost 50%. So there's a lot of temperature variability, which is quite surprising. So what that can mean for residents is that they might have to run their air conditioning and their heat within August. And it makes it harder to plan for events and utility consumption. So the other factor I wanted to consider was I wanted to look at precipitation. So I'm keeping this all in line with the box and whisker plot, and it's the same month of August, and this is looking at total precipitation. And what we can tell is that August in 2020 had a lot of precipitation, and in 2010 we had significantly less. And just to evaluate this, I also ran a regression model for precipitation and the date factor. And there was a positive coefficient, but the total amount of rainfall wasn't as surprising. So in 100 years, we'd expect to see 0.0386 more inches, which is not that much, but it's still something to be concerned about. And then for the year 2100, as that date for the carbon brief, we're going to see 0.0323 more inches of total rainfall. So it is trending upwards, and precipitation is important for water levels for Wilmington, because proximity matters. Wilmington is on the Delaware River and is 91 miles from the Atlantic Ocean. So any increase in water and precipitation is going to put a greater strain on local resources and flooding prevention. And it can lead to flood damages and people having to relocate because they're on a river that flooded. So these are important things to consider and factor in. So WWWD, what will Wilmington do? So I think we've pointed out with this analysis that temperatures and precipitation are having an upward trend. So days are getting hotter, the daily minimums are getting hotter, which is quite impressive, and there's going to be more precipitation. So what can we do about it? Well, New York City employed some carbon trapping methods, and they planted 1 million trees starting in 2007, and they had a goal to plant 1 million trees by 2017. They finished it prematurely. They finished it in 2015, planted 1 million trees, and that's part of their carbon trapping plan and strategy. Another thing that some big cities are doing to kind of alleviate the need to run air conditioning is they're painting their rooftops white and with reflective paint. So that can help reflect some of those UV rays and some of that heat off of roofs and just reduce total energy consumption. And something simple that Wilmington can do in the short term is if these heat waves keep increasing and they're more severe and they're longer, just extend pool season. So maybe open your pools a little before Memorial Day and close them after Labor Day if the temperatures keep trending upwards. So thank you. That is my presentation, and these are my references. And thank you for your time.